dimensional analysis is a method of converting units that we should be familiar with. This is, in a nutshell, how we do stoichiometry problems, converting between moles and grams and particles and all that good stuff. When you do dimensional analysis, I know sometimes people are like, oh, this is the easiest thing in the world. I can do it in my head. And obviously, you'll always be asked to show your work. So this unit factor proportion method is probably what you're going to want to do when it says show work to prove that you didn't cheat, which I know that you didn't. You're just that smart. But the people that are grading the AP test don't know you, so they don't know how smart you are. You'll be given conversion factors like between English and metric, although, I mean, we don't use these very often. But if you did need them, you would be given these. You don't have to memorize them. You don't have to program in your calculator or anything like that. One that you might want to add, so I did a little cheat here. We'll use this one in a bit. In the length, 1,609 meters is equivalent to 1 mile. I looked that one up. I cheated a little bit. There's a question later on that asks about a mile conversion, and there wasn't anything given on this chart. So I looked one up. But yeah, these would be things that you do not have to memorize. You would be given any kind of a English metric conversion that you would need. The proportion method is really, all I want to emphasize here, because this will be what they're looking for when they're grading stoichiometry type problems. You start with what you have. I have 32.0 grams of something, and leave that 0.0 in there. That's important. I don't want it in grams. I want it in pounds. So we set up a proportion. The unit that we want to cancel always goes on the bottom. The unit that I want goes on the top. If I'm lucky, I can find one conversion that gets me from grams to pounds, which there is. They give me a conversion here of 453.6 grams. 53.6 grams. And that's for every 1 pound. Boom. Now, to be honest with you, that's kind of how I set these up. I get the proportion down. I put the units in first. I want to cancel the unit that I start with. Whatever I want goes on the top. Then I'll go look up the conversion factor. And again, here's where some people want to be kind of, I don't know, maybe they're just that smart, or maybe they're lazy. And they just want to know, do I multiply or do I divide? What do I do? I just want to plug this in my calculator and be done. I don't know. Maybe sometimes you can figure out in your head, but when we've got longer conversions, and especially stoichiometry, you want to set that up. So I put the units in first, and then I know that the numerical values are in the right spot. And again, I am kind of obsessed with canceling my units. So when I get to this point, obviously I can plug it in my calculator, but it just gives me some kind of excitement to go like that. I cancel grams, they're gone. The unit that I have left is pounds, and that's exactly what I want. When the number's on the bottom of the proportion, we divide in our calculator. And now I get this number, and I have to think about sig figs. I know the unit's going to be pounds. When we do dimensional analysis or stoichiometry, any kind of a constant is not used when rounding your final answer to correct significant figures. So that could include these constants, I guess you could call them, these English to metric conversions. It could include any molar mass off a periodic table. That is not used when we round to sig figs. All I need to do is look at the original measurement. The original measurement had 3 sig figs. That last 0 counts because he's behind a decimal spot. So when I plug this in my calculator, I will leave my answer with 3 significant figures. And I get a small answer, 0.0705. That 0 in the front is a leading 0, so that guy is kind of a freebie. He is not a significant figure, just the 705. So that's what we're looking for in a dimensional analysis type problem. If they say, show your work, that's what we want. Sometimes you might get something like this second one, and maybe they give you a chart of conversions, kind of like what's listed here, this English metric equivalence. and you say, ooh, darn, I don't have anything that gets me straight from inches to yards. But I do have an inches to centimeters, and I can kind of play with that. Maybe I can put that to work. So I'm starting with 100.0 inches. I do not want it in inches. And there is a conversion that gets me to centimeters. So that sounds kind of fun. Let's put that to use. 2.54 centimeters for every 1 inch. There we go. Inches are gone. So right now I'd be in centimeters. If I wanted to, I could plug this in my calculator. The other conversion that's listed in length is actually meters to yards. So here is where some people will plug this in their calculator. They'll flip the decimal spot. Going from centi to meters is not a big deal. And then they'll do the conversion from meters to yards. Totally fine. If you wanted to, you could set up another proportion. You could do, I don't want this in centimeters. I want it in meters. And you could set this up here, a few different options. You could say, well, I know centimeters are small. It takes 100 centimeters to make up 1 meter. Or you could use, we'll just put this up on top. Now let's say you had a conversion, you were switching out of centi into meter. You could say 1 centimeter is 10 to the negative second meters. Either of those two would be 100% equivalent and acceptable. Or you could just plug that first conversion in your calculator and move the decimal 2 spots. So right now I'd be at meters, and then I could use that last conversion that's listed in the chart. I do not want this in meters. We want to go to yards, which I don't know why we would ever want to measure in yards in here. We're never ever going to use yards all year long. We're not going to use yards. 1 meter is about 1.094 yards. 0.94 every one. I can cross off meters. The only unit I have left is exactly what I want, yards. So I can plug this in my calculator. I multiply numbers across the top. I divide by anybody on the bottom. My original number, 1, 2, 3, 4 sig figs. With a decimal spot at the end, all those zeros are significant. That last zero after the decimal must have been my estimate. So I need to leave 4 figures. I plug this in my calculator. I'm going to leave the first 4. 2.779. 779. Done. Lovely. Another option might be like this last one, switching rates. Miles per hour to meters per second. And this is where I was like, well, there's nothing in that chart that has miles. So I looked up the conversion that goes straight from miles to meters, which is exactly what I wanted. We've got 65 miles per hour. I'm going to write it kind of like miles per 1 hour. You can fix the time first. You can fix the distance first. It doesn't matter. Maybe we'll use that distance, that miles to meters. Let's use that first because that should get me exactly where I want to go. I do not want this in miles. We want it in meters. The unit I want goes on top. What I want to get rid of goes on bottom. 1 mile. There we go. 1 mile was 1,609 meters. I just looked that up. But that was a quick fix. Miles and miles cancel. And I'm in meters, which is the distance unit that I want. Now we got to fix hours. I want to go hours to seconds. And again, there's different options, but this might be the most straightforward. I do not want this in hours. If I want hours to cancel, they have to be on opposite sides of the proportion. So if hours is starting on the bottom, I want to put hours on the top. Quick switch, hours to, how about minutes? I know that off the top of my head. 1 hour is 60 minutes. Hours are gone. Bye-bye. There you go. And I don't want this in meters per minute. We want meters per second, so we'll do one more. I don't want minutes, so to get minutes to cancel, I have to put them on the top, so they're opposites. I want seconds. Every minute should be 60 seconds. And if you wanted to, you could figure out how many seconds are in an hour, and you could do this in one quick switch, too. Minutes gone. The units that I have left are exactly what I want. Meters per second. Plug it in your calculator. We multiply across the top. We divide on the bottom. My first number has 2 sig figs, 65. So we are going to leave this as 2 sig figs. 29 meters per second. So again, none of those conversion factors are used when I round my final answer. I only go back to the original measurement.